And next we have a arbitration field. It have a identifier of 11 or 29-bit identifier. So it will give like what type of CAN we are selected, whether the standard or extended. RTR will be there. So RTR will be like a it will decide like whether the message we are sending or we are whether it is requesting the message. So sending the message is a data frame. It will be a 0, and the dominant it will be means a dominant will be a 0, and remote frame it will be a 1. It for recessive. So remote frame like we are requesting the data. And next will be the identifier extension. So IDE, it will for 11-bit and 29-bit will be there. So IDE will be 0 for standard. Extended, it will be a 1. And next we have a control field. Control field have the data length code. So where the 8 bytes of data you need to select. Based upon the selection of the bytes that you need to transfer, this control field help you to decide how many bytes of data that you need to transfer. And it have the generally it have the 4 bits. With the help of the 4 bits only, we can able to decide how many bytes we are able to select, and remaining 2 are reserved. And next we have a data field. So data field is the actual data that the messages or signals that we are transferring. So that will be comes under a part of a data field. So usually it varied from 0 to 8 bytes. Okay. So based upon the control field that what we selected. Next we have a CRC field. So CRC, it is used for error correction. So whatever the data that we are transferring from master to the slave. So during that time, if any errors is happened, or the messages are got corrupted, it is not able to transfer efficiently. So you will get a CRC field. Means what exactly happens is it will keep on checking the messages which are receiving properly, or if it not able to receive. So that we will do on the CRC field. So it have a CRC slot and CRC delimiter. CRC slot, it have a 15 bits. So that 15 bits will do the operation, like whatever the data that you are sending. And the CRC delimiter, it have the always recessive. It cannot change when during the transmission or error. So if in case it changes to 0, that will be there will be the error. So in the whatever the data we are sending. So in interviews only, you need to say it is always 1 in the frame format. Okay. So I will tell you the errors, what exactly will happen. If it is changes to 0 means the dominant, then we are getting the CRC error. And next, so whatever the data that delimiter, if it is 1 means, it will say that uh, it is used for a resynchronization purpose, synchronization of the data. Like what it will be keep on, we are sending the messages, right? So that without clock, it should be sended. So that sync should be required for sending of each and every message. And next we discussed about the acknowledgement field. So acknowledgement field is for each transmission messages, you need to send the acknowledge. You need to acknowledge to the sender, like I received the data. Okay, so now can we send me again like the data. So like we need to request to send. So once the data is sended, you need to acknowledge like I received the data. That's fine. Like that, you need to give some response. It is that response will be part of the acknowledgement field. So we have the acknowledgement slot and acknowledgement delimiter here. So acknowledgement slot will be it indicates that the whatever the request you are making to send, and it will changes to 0 to 1. Okay, so 0 means say the dominant, and 1 means recessive. What happens exactly is, whenever, as I told you, recessive state means which we are it will be in an ideal state. Okay, and dominant state means it will be in a the data which we are sending, that we discussed. Don't confuse with the recessive or recessive state and recessive. Okay, recessive state means the changing of 0 to 1. Okay, so that will be the recessive. And if you say individually the recessive, right? Like if I mention like 1 recessive. Okay, so if I mention the recessive state, if I mention, it is changing of 0 to 1, means it is changing place from 0 to 1. If I mention a dominant state, so dominant state means it will be a 0. Okay, so means dominant means it will be a 0 only. So dominant state means it will be changing from 1 to 0. Okay, this is the points you should remember. Don't get confused. Yeah, so here also it's happening the same, like whatever the data, if receives correctly, no, it is changing from 0 to 1. Okay, so 1 will be there. So whenever the data you are, whatever the data you are sending, it is correct, means the acknowledgement slot will become 0. Sorry, it will be 1. It will change from 0 to 1. If this whatever the data you are sending, it's not correct, right? So then this acknowledgement slot is, it will be in 0 state only. There is no data is transferred. Okay, this is yesterday, as I told you, the same points. You can just, we are revising it again. And next we have the uh, acknowledgement delimiter. So the acknowledgement delimiter, it is always 1. Okay, so where this will be changed to 0 if there is no acknowledgement is sent. Okay, so that is a different concept. We'll discuss it further. And these are the delimiters. So here the CRC delimiter acknowledgement delimiters are used for the separation. Okay, separation between the CRC acknowledgement slot, the CRC field used, and here this acknowledgement field is used for to the separation between the acknowledgement slot and the next message which you need to send it. So for that purpose, this acknowledgement field will be considered. And finally will be the end of frame. So end of frame always ends with the 7 bits. So this is a always once recessive. Okay. So hope you understood on this basic overview, like what are the fields and what is the information it have. And so like we started discussing about the data frame formats. So like how we are sending the data in the standard frame and extended frame. So coming to the standard frame, like we are sending SOF message ID, and so whatever the message ID, we'll select the 11-bit identifier. So we like 11-bit means, so we are able, whatever the messages we are able to choose, right, like 0x 01 02. So like that we can use up to 2048 unique IDs. So these are the message IDs we say. So each message, it have the signals. So okay, so that we are selecting from this point. And next we have the arbitration field, we have the IDE, and we have the OTF. So next we have the control field, it have the reserved and the DLC and data and the CRC field, acknowledgement and end of frame and IFS. So and the extended data field, it have the same, but only the difference will be the IDE. So here it will be the 11-bit, it will be the 29-bit identifier, and we are able to select unique IDs of 356 unique messages. So here additionally we have the SRR. So in standard we don't have, but in extended we have the SRR. It is a substitute remote request. And next we have the IDE. This IDE will be one. Both SRR and IDE will be one in this case. And we have the message ID. This will be 18. And next we'll have a OTF. It is a common for standard and extended. So remaining all, it will be same as per the above. And next, the data frame, it have the identifier, just to revise these points, like identifier 11-bit, and we are able to send 8 bytes of data at a time. And it is for used for the smaller identification number, more like low speed or less number of identifiers we can use it. And next we have the extended. So only the difference will be in arbitration field. So we get the identifier will be 29, and it will be a CAN 2.0b. And we can transfer data up to 64 bytes of data at a time. So it is used for larger identification numbers. So next, coming to the remote frame format, we need to discuss it starts from now. Like the remote frame format is where we are requesting the data. Like who will request the data? So we have a master. So the master will say that master will send the data. Who is requesting the data? Okay, so like slave always request the data to send some messages. Okay, so then only the whatever the master it have the data, so that data will be transferred to the slave. Okay, so first you need to get the request from the slave to the master, then master will send the data. Master sends the data. Master sends the data to slave. Okay, so how this request is happening? We know about what is the data, how it is sending. So we have the data format. Now the slave is requesting. What is the format of the slave that it able to request? Because in a multi-node communication, we have plenty of slaves. Like imagine these are the nodes in the network. Like I am creating many nodes. Okay, so it is this is a star, like a star topology. Okay, but our CAN is a linear topology. Okay, so linear means it will be the single bus where multiple nodes are connected. Okay, it will be like this. This is a linear topology. So if someone asks you to draw the CAN network topology, you need to draw like this. So here I have the ECU, electronic control unit 1, ECU2, ECU3, and ECU4, ECU5, and ECU6. Like this we have. So what we are doing is just we have the CAN, and with the help of the CAN we are connecting the wire. So now like consider this is a master. So, okay, this is a master and others are like slaves. Now, like who will send the data? So that will be acting as a master. Now this ECU2 is sending the data. Now others are like slaves. So let's consider like my data is ECU5. So ECU is a slave. So this guy need to send a data to this slave needs a data. So this data who will send? The master will start sending the data. Okay, let's make it like the master and slave here. So slave need to request. So that request should have some ID, like who is the slave and what is the number it's sending. So all those details should be required because master need to understand like whether it is coming EC1 or EC5 or EC3. Such details it requires. So then only the master can send the data to the slave. Okay, so like in both CAN types, like standard is a like 11-bit identifier, and extended will be 29-bit identifier. Both phases, the request should be followed. So how the request will be and what the format will be. So the frame format, it will be like the same as the data format. Okay, so in the standard, we have the startup frame. So startup frame, it will be like a 0. So whenever it is requesting, also in interviews, they will ask you when you are transferring or requesting, what will be the startup frame? It will be always 0. Okay. So next, coming to the arbitration field, because this will give the ID, like which is the ID that you are able to communicate and what are the messages, those information will be there. Next, we have a ID. So this ID, it will be a 0 for a remote frame. Next, we have the RTR. So RTR, this is a very important field. Okay, so this field will tell you like whether you are requesting the data frame or a remote frame. So in case of a data frame, what it will be, in case of remote frame, what it will be, the RTR will be uh, 0 or 1. So what is the option? Like in data frame, when you are sending the data, it will be 1, right? 1 or 0. In data frame, like it's
Zeros.
just about frame, right? Frame format. So when we are sending the data, so that time data frame, it will be 0 or 1.
0.
Are you
Zero.
sure? 0. Okay. So now that 0 means it knows that we are transferring the data, right? So now this data frame is 0. Okay. And now remote frame is 1. So remote frame it will be 1 means, so now RTR will be a 1. It's saying that it is in a remote frame. This is a one very important field you need to remember. Okay. And next, we have the same like control field, because you need to mention how many bytes of data you need to request. So that will be the control field. Here also it will be the same, like 2 are reserved and we have a DLC. So the data that will be selected. So next, we don't have one field. What is that field? We are missing one field here between control field and CRC field. And anyone
Data
can tell?
field.
Data field. Yes, exactly. This is very, very important. We don't have a data field in remote frame. Okay. We don't have data field in remote frame. Okay, that is one difference. And the RTR will be 1 remote frame. These are very important points you need to remember. Okay, you can write down in notes in standard frame. Okay, standard remote frame. You can write out in standard remote frame. RTR will be 1. That is recessive. Next, don't have data field. Don't have data field. Okay. Is it clear now? Okay. So this is the point. Okay, where you need to remember. And next we have a acknowledgement field. So acknowledgement field, we have the acknowledgement slot and delimiter. Okay. So this whatever the bits, right, it will be a 15 bits, and this will be the 1 bit. And acknowledgement slot, we have acknowledgement slot and acknowledgement delimiter. So as I told you, when we are transferring the data, right, during the transmission, it is changing from 0 to 1. Okay, 0 to 1 when you are sending the data. So when you are acknowledging, right, so during the acknowledgement, this data, whatever the slot and delimiter, okay, so this slot and delimiter, it will be a 0. So 0 for remote frame, remote frame, and 1 for data frame. Means it is during transmission, right, it is changing from 0 to 1. The state is changing. So that is what the data frame it will be. So this you need to say in introduction. This is acknowledgement slot and acknowledgement delimiter. Okay. So this is a one point. So what exactly will happen is whenever you will get the errors, so this acknowledgement delimiter, it will change the value. Yeah, that's it. Like these are very important points, RTR, and it won't have the data field. Okay, so next point will be like end of frame. It have a 7 bits. So the 7 bits will be all ones. And in the IFS, so this will be a 3 bits only. So it is the just a space of separation between the other messages. Other message will transfer message to message 2 it will be, and this enter it will comes as a message 1. Okay. So next coming to the extended. So extended also it's same. Only the difference will be in the arbitration field. It have the SRR. So this will be 1 and the ID will be there, message ID. So all will be same. Only the difference it comes is even this RTR also it will be 0. So for dominant and 1 it is for recessive. You can write down these notes also. Dominant and the other important things is the arbitration, we have the SRR, IDE, and this difference. And next we have a point of it won't have a data field. Don't have data field, and RTR is 1. That is recessive. Or this is for extended remote frame. Both points are same. Nothing is changes. Only the changes will be the arbitration IDs, SRR, and this fields. Okay, is it clear? So when slave is requesting for the master to send the data, it will be like this. Okay, I'm able to hear. There is no lagging with the communication, right?
Yes, no.
Yes, sir, clear.
Okay, thank you. So next is coming to the errors, because whenever you are sending the messages, right, there is a chances of getting errors. Why these errors we usually get? Because whenever you are sending the messages, it will be like a first message you will send in 10 milliseconds. Again, other message you will send in the same time. Okay, so two messages when you are sending in same time, there is a chances that collision can happen, and because of that collision, the both messages will lose the communication. It cannot transfer to the other end. So for that, again, you created some noise or some disturbance in the network, means during the transmission. So due to that also the errors can be happen. Okay, and whenever you are making the communication between the two devices, it should follow stable and it should be communicated stable. So then only it will deliver the messages successfully to the master, to the slave. So here the errors have a two types: active error and passive error. You can write down can error frame, can errors. You can write out the heading can errors, active error and passive error. Can error frame format. You can write down can error frame format, active error and passive error. So what is a can error frame format is can error frame format. It to indicates the error. Okay. So there, as we told, like we have it two types: active error frame and passive error frame. Okay, let's you can draw the simple block diagram of the active error frame. So it is very simple usually. So you can draw like this, a small box, and it is an error flag. Error flag will be there, echo. Okay, so can make it. So error flag, we have error echo and error delimiter. How you can draw? You can draw like this. So this will be a 6 bits and this will be a 12 bits. In this 12 bits, sorry, this will be 8. So this 12 and 8. Okay. So here this 12 will be splitted into 6 bits here, again 6 bits here. Okay. So what this 6 bits will give the information is, it indicates that error flag, and you will get a error echo. And this will be error delimiter. Sorry, diagram is not clear. So can draw my this error flag and error delimiter. Sorry, error echo and error delimiter. Okay, so this will be the 8-bit. This will be the 12-bit. So here the completely it will be split into 6 bits and 6 bits. Okay, but actually this is completely we need to consider because the bits can vary. Okay, so this all are same, like this completely 0 0. If you are able to see the error flag, it have a 0 0 here, and here also we have a 0 0. Means this complete 6 plus 6 12 bits are 0. Okay, and delimiter, if you see, all are ones. Delimiter, it have all ones. So these are 8 bits. 8 bits are 1. Okay, so this will be the active error. Okay, so whenever the error flag and error echo all are zeros, and error delimiter, it will be a 1. So that time it will be active error. So what is the purpose of that active error is, so an active error occurs when node. So here node is our ECU, our microcontroller. Okay, whenever the controller detects a critical error, so whether it is a sensor fault or the switch fault, it is that will be complete the critical error. That condition during the communication on the CANBus means whenever you are started communicating right with from the device, so that time you got one error from, you lost some communication on the network or you missed any one of the wire. In that case, you will get this active error. Okay, you can write down active error. Active error occurs when node detects a critical error. You can write down the same sentence. An active error occurs when a node detects a critical error condition during communication on the CANBus. Okay, so next will be the passive error. So passive error, we have like active error, we are able to see all are zeros, right, in the error flag and error echo. But in case of passive error, it will be differ. Always ones will be there in the error flag and error echo. Okay, so this will be the passive error frame. Okay, so here also it will be the same. Here, whatever the error flag and error echo, it will be in the ones, and error delimiter, it will be all ones. So the complete error flag, error echo, error delimiter, all will be ones, but it won't affect much, because whenever 0 means the transaction is happening means, so it is saying that it is a critical. So but in a passive error, it won't be a, not it is not impacting, means the message is coming and it's going, message is coming and it is going, like this it will. So whenever it's happening with the less duration of the time, so that time it is not impacting the component or the system. It will be in a, like it is not a much critical. Okay, so you can write down the sentence: a passive error occurs when a node detects a non-critical error condition during the communication on the bus. So this point is enough, like during the interviews or discussion also, like what active frame, like can you draw the active frame error or the passive frame error? You can give this frame and you can explain what exactly. Okay. So whatever the errors we are getting right, it have different types. Going forward classes, you will need to know like the message level, how you are getting, and bit level, how you are getting the messages. So those are important concepts. Going forward, we'll discuss. Did you completed this active error and passive error? What is a frame? What is the definition of this?
Sure.
Okay, these are very simple only. Don't make it, but you need to remember these concepts. Okay, so because in some of the like who are more experienced, like 10 years or 15 years of experience, or you are going as a tech architects. So that time they will ask you this type of questions. But for 4 years, 6 years, 5 years, they will ask you on top level, like what is the frame format for the error flag, how it will be. You have any idea on this? Like that, they can ask. You can, if you remember, you can answer it. If not, it's fine. Okay. But learning as an expert, we should learn, and we need to give the good presentation to the interviewer, so that makes them good confidence to get you in the organization. Okay, and next is a overload frame. Like overload frame, we discussed if there is a delay between the data frame or remote frame when we are sending the messages. So if you look here in the block diagram, right, like we can discuss this concept here. Sorry. So we have a data frame, like DF is the data frame, RF is the remote frame, EF is the error frame, and overload frame. These are the 4 frames. Okay, let's consider this is my CAN network. Okay, so we have the high and low. So what exactly here it's happening is I am sending one message. Okay, so I got a request. Now I am sending one message. This is a message 1 and message 2. I am sending 2 messages. Okay, so it carrying 2 messages. Now again I made a request, other message. Again I'm making the request in between the messages. So the message of 3. So again the message of 3 is started, DFM3, DFM4. I requested 2, so it is sending 2. And now again I'm sending the DF4 again and again. Okay, but I'm not requested. Without request, if I try to send the message and again, so what happens is I'm getting the error. So that will be the EF I mentioned. It is a error frame. So it will be created because the error, whatever the request we didn't do, but still we are able to try to send the message, uh, that creating an error. And when we are sending the message, right, one after the other messages, then we'll get some delay in the network. Means within the messages, the overload will be created. Means there will be chances of overload frame is the messages you will keep on sending continuously, repeatedly within a time. Like you need to send at 10 seconds every time you need to send the message. Instead of that, the message you are sending at 6 seconds or 5 seconds, the message, or it's not completed the sending within the time you are trying to send. So there will be a part of a collision will be happening. And when you are sending the messages, you should not give more gap. So that will be the overload frame, or the space that we are giving between the 2 messages to send the data. Okay, so coming to the overload frame, how it looks. So it will be like same the error flag, like it will be. Only the difference will be the bits. So like it will be similar to the active. Okay, active error, So here all 6 bits will be in the 0 in the flag, and in overload echo also we have the 6 bits. This is also will be 0. Okay. So next we have the 8 bits. This 8 bits are the delimiter. So whatever the data that we are sending the messages, we should be send it within a time. So what is the definition of this overload frame is? So overload frame sort the signals that are a nodes is overwhelmed. They tell we need to adjust the other nodes. Now don't send more messages. So whatever the messages are there, I need to adjust. So that is a indication. So we are giving here. You can write down overload frame. Overload frames are signals. Overload frames are the signals that in a node is overwhelmed. Overwhelmed. A node is a overwhelmed. Okay. Meaning why I'm using the overwhelmed. So whatever messages we're sending, right? So we need to fill the complete of messages. Okay. So like assume that in the network we need to send the messages. That messages need to be completely filled in. Okay. So when you are